Okay, so today we're going to be learning how to apply a trigonometric substitution, and this is a fairly ugly integral which requires us to complete the square first before we can get anywhere. Now, an indicator that we have to use trig sub, we have a square root, and under square root we have something squared, and if we let that equal u, we're not going to really get anywhere, it's just going to make it worse. So that is a good indicator that we're going to have to apply a trig sub. Now, we can't really apply a trig sub yet because this is an ugly form, and how we fix that is by completing the square. So let's do that together. So we say firstly, let's put whatever's in our square root. Okay, completing the square. First thing we want to make sure is that we don't have a coefficient here in front of the x squared. That's checked out, so we can just complete the square. So copy that down. Now what do? We take this middle term, we divide it by 2, that's going to be 1, and we square it. So we said it's going to be 1, and we're just going to put it as a squared. Okay, plus 5. Now we've changed this equation, this quadratic equation. So in order to keep it the same, we're gonna have to minus a 1 squared, because notice normally we'd have an equal to 0. What would we do? We'd add a 1 squared on the other side, and because we added that 1 squared on the other side, what I'm doing is minusing it here so that we keep the same form that we had. So notice we didn't change anything, we are just changing the form. Okay, now completing the square. So what do? I take this term, square root it individually, take the last term, square root it individually, put it in a bracket, and then square it. Now how would I know if it's correct? If I have to square this out, okay, square the first term, multiply all these together, so 2 times x times 1, 2x, square the last term, and we have the same, oops, not there, we have the same thing here. Okay, so now the 5 minus 1, that's going to be 4. Now if we have to square this whole thing and then add the 4, we're going to get back here. So that's how we know that we did it correctly, and we didn't change anything, just changing the form. Now how would this help me in any way? Well, this integral now is going to be this, x plus 1 all squared plus 4. How does that help me? Well, instead of memorizing how to apply trig sub, I like to draw my triangle all the time. Okay, this helps me visualize what I'm actually doing. So what do I do from here after drawing my triangle? Okay, so let's think about a squared plus b squared equals c squared. Let's focus on this part, a squared plus b squared. Notice that if this is a, okay, that part that I highlighted is a, that's a squared, and this part is b squared, because we can say that's the same thing as 2 squared. Okay, so now because that's in the same form and that's equal to c squared, we can call this hypotenuse this whole thing. Okay, now to choose which one goes on the opposite side, which one goes in the adjacent, well, let's think about what identity we're going to use. Now with practice, we can see that here the only identity that we can use is tangent squared plus 1. What is that? That's secant squared. Okay, so what I'm getting at is that we want a tangent theta. How do I get that? Well, tangent is opposite over adjacent. So normally you want to go with the x over the constant, whatever the constant is. So in this case, our x is this whole thing here. Okay, so that's going to be x plus 1. Now here, please don't make the mistake of writing 4. Okay, we have to root it, so this is going to be 2. Now tangent is going to be x plus 1 all over 2. Multiply both sides by 2, get 2 tangent theta is x plus 1. Now I'm not going to minus 1 on both sides, because now when I take the derivative, we get the same thing anyways, because this one would become 0. Okay. Now we have everything we need to substitute into our integral. So dx is going to be 2 secant squared theta d theta square root. Okay, x plus 1 is this whole thing. So we're going to write our x plus 1, 2 tangent theta, and then squared, and then nothing happens to the 4. Okay. Now, normally I would do the denominator in one step, but since it might cause some confusion, let's do this together. So if we square this, this is going to be 4 tangent squared theta plus 4. And this is why I do it in one step, because we have to keep writing the whole integral. So here we can factor out a 4, so then this becomes tangent squared theta plus 1. As you can see, the identity that we wanted to use earlier. And now with square roots, if we have a times b, this is going to be square root of a times square root of b. So basically what we can do here is 2 secant squared theta d theta all over root 4 multiplied by root tangent squared theta plus 1. Okay. And with practice, you can see that you can go from this step all the way there in one step. So now, hopefully we realize that root 4 is 2. These 2's would cancel. So now we have secant squared theta d theta. Let's do the identity in one step. So tangent squared theta, that's the identity of secant squared theta. Now if I square root this, it's going to cancel out that exponent. So we have secant squared theta d theta all over secant theta. We cancel one out, so we get the integral of secant theta d theta. Now, if you know the table of integrals, I'm not even sure if it's there, but the integral of secant theta is ln secant theta plus tangent theta. But I'm gonna do it anyways. So how do we do this integral? Well, actually I'm not gonna write this down. I'll just do it in this step. So what we do is we multiply the top and bottom by secant theta plus tangent theta all over secant theta plus tangent theta. Now why can we do this? Well, this whole thing is just 1, so basically multiplying by 1. So now let's distribute this into there, so we get secant squared theta plus secant theta tangent theta all over secant theta plus tangent theta, and let's not forget d theta. Now here, why did I put an equal to? Here we let u equal secant theta plus tangent theta. Why do we do that? Hopefully you can see that if we take the derivative, then this is going to be secant theta tangent theta plus secant squared theta d theta, and that's what we have right here, just in a different order. So what does that mean? That means that this is the integral of, now we said that's du, so du over, we said that's u, so du over u, we could just write this as 1 over u du. Now the integral of 1 over u is ln, absolute value of u, plus c, and ln, what is u? U is secant theta plus tangent theta plus c, and we are still not done. So last thing we want to do, and the reason why I went through that so quickly is because, well, you don't really need to do all that. You could just memorize this, but it's nice to show how it comes about. So the final thing we want to do is replace our secant theta and our tangent theta. Okay, come back to our triangle. So secant theta, cosine theta is what? Adjacent over hypotenuse. So this is going to be hypotenuse over adjacent. That's our secant. So here we have ln of, I might need 2 lines for this. Okay, so ln of that thing tangent theta is what? X plus 1 over 2. We can combine these, so we get ln x plus 1, this whole thing, all over 2, and plus c, and we are done. That is the final answer, and here is the entire solution.